Welcome to This Explainer. Today, we're diving straight into how a tiny rogue group of hackers practically forced multi-billion-dollar tech giants to completely rethink their entire approach to security. We're talking about a saga that literally reshaped modern tech as we know it, moving the battleground from basic software patches to physically unpatchable silicon. So, if you were following the console hacking scene back in the late 2000s, you probably remember this massive explosion of tools, homebrew channels, and jailbreaks. It was everywhere. And then, poof, it kind of felt like the biggest names just vanished into thin air. But did the world's most famous console hackers actually fall, or did they just evolve? Well, let's trace this incredible journey. We'll follow them from their roots in innocent consumer homebrew all the way to serious, hardware-level academic security research.
Part 1. The Wii Homebrew Playground and the Formation of Team Twiizers.
Right, so our story kicks off back in 2006 with the launch of the Nintendo Wii. A collective of researchers got together and formed what they called Team Twiizers. Now, here's the thing. Their goal wasn't piracy. They just wanted total, unfiltered system understanding. But to get that, they had to bypass what Nintendo called a split privilege model. Basically, you had the main Broadway CPU, which ran the games, but those games couldn't touch the hardware directly. If a game wanted to read a disk, use the USB ports, or even just save a file, it had to ask this separate, isolated coprocessor called Starlet first. Starlet controlled absolutely everything. It was the ultimate gatekeeper. So naturally, Team Twiizers realized pretty quickly that if they wanted to really understand the Wii, they had to somehow trick or bypass this gatekeeper.
And that kicked off a relentless cat-and-mouse game with Nintendo. In 2008, they found their first real crack in the armor with the Twilight hack. This was a super clever buffer overflow, essentially cramming too much data into the system's memory to sneak in unauthorized code, all hidden inside a modified save file for The Legend of Zelda. But, having to boot up a specific game every single time you wanted to run custom code, kinda tedious. So, they stepped it up. They built the Homebrew channel, which slapped a permanent, really elegant user interface right onto the main Wii menu. Naturally, Nintendo patched the Zelda exploit, so the team escalated again. Enter LetterBomb in 2009. This was a bug in how the Wii read SD cards, meaning you didn't even need a game disc anymore. And when that got patched, well, they unleashed LetterBomb in 2011, sending a payload directly through the Wii message board. They were just constantly outsmarting Nintendo's software engineers, bringing Homebrew to millions of everyday users.
Moving on to Part 2. The PS3 cryptographic collapse and Sony's fatal mistake.
Okay, so now we hit the real rupture. This is the era where absolutely everything changed. The team expanded, rebranded themselves to Fail Overflow, and set their sights on the PlayStation 3. At the time, Sony was pretty confident their security architecture was mathematically invincible. But, and this is a massive but, Sony made a catastrophic mistake. See, the PS3 used the elliptic curve digital signature algorithm, or ECDSA, to verify that software was officially trusted. Every single time a signature is generated, the math requires a completely random number, a nonce, which is known as K. The absolute golden rule of ECDSA is that this K value must never be reused. Literally, never. If you reuse it even once, the crazy complex encryption just crumbles into basic high school algebra. And what did Sony do? They hard-coded a static K value. They used the exact same number over and over again for their digital signatures. Because of this massive blunder, their ultra-secure private keys could just be derived mathematically. It's like building an unpickable vault and then just taping the master key right to the front door. The fallout from this discovery perfectly illustrates the massive divide that happened next. At the 27C3 Hacker Conference in late 2010, Failed ZeroFlow got on stage and presented their theoretical research. They proved, mathematically, that the PS3's trust chain was permanently broken. But crucially, they stopped there. They didn't release the keys. Enter Geohot, also known as Geohot. He took their math, extracted those usable root keys himself, and just dumped them straight onto the public internet. Chaos, absolute chaos. Sony brought down a massive legal hammer. They launched aggressive DMCA lawsuits, subpoenaed IP addresses, seized physical hardware, basically turning this somewhat tolerated gray area hobby of console hacking into a severe legal hazard overnight. Which brings us to Section 3, a shift in philosophy, entering the post-PS3 era. You can imagine how that intense legal crossfire completely altered the group's trajectory. It triggered a total psychological metamorphosis. Back in the pre-2011 days, when they were Team Twiizers, they were all about releasing consumer tools, turnkey jailbreaks that literally anyone's grandma could install. They wanted to build this vibrant, open ecosystem for homebrew apps. But post-PS3, operating as failoverflow, they completely abandoned that.
No more user-friendly tools, no more mass-market piracy enablers. They pivoted exclusively to strict academic security research. They'd figure out the theory, demonstrate the flaws, and publish their findings, but they absolutely refused to hand out those simple one-click exploits. They firmly drew a line in the sand to separate themselves from the piracy scene.
Section 4, exploiting the boot ROM and the beginning of the hardware war. Carrying this strict new philosophy forward, the group entered what we can call the hardware war. Eventually, they set their sights on the Nintendo Switch. Now, to grasp how huge their breakthrough here was, we need to talk about the boot ROM. The boot ROM is the initial code etched directly into the physical silicon of a device's chip. It's the very first thing that wakes up when you press the power button, acting as the ultimate security anchor. And here is the crucial takeaway. Vulnerabilities in the boot ROM are physically unpatchable. You can't just push a firmware update over Wi-Fi to fix etched silicon. Once that boot ROM is compromised, every single one of those millions of physical consoles sitting in people's living rooms is vulnerable forever.
Let's actually break down how they did this with their famous Shof L2 exploit on the Switch. It's a fascinating four-step process. First, you have to force the device into a low-level USB recovery mode that's baked right into its NVIDIA chip. Step 2, a connected computer sends specifically malformed USB control requests to the console. Now, step 3 is where the magic, or the failure, really happens. The unpatchable boot ROM completely fails to check the length of this incoming data. It just ignores the buffer boundaries. So step 4. This causes a massive memory overwrite, which lets the attacker execute their own code before the Nintendo operating system even has a chance to boot up. Basically, they hijack the system before the console's security guards even had time to tie their shoes.
But true to their new post-PS3 code of ethics, look at how Failoverflow handled this massive victory. They published the complex theory, they dropped the source code, the deep technical explanations, all their raw research notes, but absolutely zero user-friendly tools. No handy installers, and definitely no step-by-step YouTube jailbreak guides. They entirely stepped away from the end-user experience. And this actually caused a huge rift in the community. The scene permanently split between the high-level academic researchers analyzing silicon architecture and the everyday consumer modders who were left scrambling to piece together their own usable tools from the ashes of Failoverflow's high-level math.
And finally, Section 5, a permanent industry legacy, reshaping silicon itself.
It's wild to think about, but this small, tight-knit group of hackers cast an immense shadow over the entire technology sector. Because of Failoverflow's relentless pressure, tech giants suddenly realized that relying on software patches just wasn't cutting it anymore. If your foundation is cracked, the whole house is coming down, right? So this kicked off a whole new era of closed silicon warfare. Defense mechanisms shifted completely into sealed, unpatchable hardware. Nowadays, modern devices use hardware-backed secure enclaves just to generate keys. No more trusting software to pick a random number like Sony did. We're seeing incredibly strict validation for those early boot stages. Debugging interfaces that engineers used to leave conveniently open on chips, those are now physically burned and fused shut at the factory. And systems use isolated trust zone separations, which basically means that even if you do manage to hack the software, you're just trapped in a tiny, powerless cage.
So, let's circle back to that question we asked at the very beginning of this explainer. The whole idea of their rise and fall, it's completely misleading. Actually, scratch that. It's just wrong. They didn't fall at all. They transitioned. Their technical capabilities only grew more and more advanced. They evolved from building simple software installers into absolute pioneers of low-level cryptographic hardware, even as their mainstream consumer visibility kind of faded into the background. I really want you to take a second and absorb this quote, because it perfectly captures their ultimate legacy. Real-world systems fail due to engineering mistakes, not math failures. Failoverflow proved to the entire world that cryptography on paper is practically unbreakable, but it is entirely dependent on the discipline of the flawed human beings actually implementing it. A single lazy line of code, a thoughtlessly reused number, or a forgotten buffer check in silicon is literally all it takes to bring down a billion-dollar fortress. And I'll leave you with this thought about the future of this endless cat-and-mouse game. As tech giants continue to build these increasingly sealed, heavily protected, hardware-locked ecosystems, we're talking everything from our gaming consoles and smartphones all the way to our cars. What is the next generation of unpatchable silicon flaws going to look like? Because as Failoverflow so brilliantly showed us, no matter how deep the security goes, a single, tiny engineering mistake is all it takes to break the whole system wide open. Thanks so much for joining me on this explainer, and remember to keep questioning the technology you interact with every single day.